Let's see. Cool. Cool. Great. Yay. Hey, everyone. How's it going? Do you have a good long weekend? Yeah. 3 days. Did everyone just study the whole time? Or did you like actually? I can't tell if that's like you're laughing because it's true or there's no way that you were studying the whole time. I don't know.
That's too early.
Right on. Cool. So we have a super packed day today. We're kind of condensing what was 2 lectures into 1 lecture, but that's so that we can get into containers sooner and not wait for kind of mid-semester to get into containers. So let's just kick some things off. Yeah, assignment 2, that's going to be due this coming Sunday at midnight. And quiz 2 is going to open on Thursday, and that's due Sunday at midnight as well. So did everyone get to quiz 1? We all remember to do it. That's like that timing was okay, opening Thursday at 5, and we're all good? Yeah? Okay, awesome. So assignment 1, there's really, really great engagement in Slack about assignment 1 for all of the Windows folk who, called out issues and helped each other out and helped me out. I really appreciate you. I just wanted to, call out some bug fixes from all of you that got incorporated into the assignment, so they'll be in place for next semester. Yeah, just adding instructions to update PyEnv after you install it. Good point. Moving the set execution policy to after the PyEnv install. I fixed that broken link in the GitHub student pack sign up, so that doesn't go to a Notion page anymore. That goes to the actual link. Yeah, just improving some language around like cloning the GitHub repository so that it's like your own individual one. And then there was one other bug, which is adding a missing date in the syllabus. So for I think quiz 8 or something didn't have a due date, so I just added that in. It was in the calendar for the course, but now it's also in the syllabus. Yeah, so let's just talk about assignment 1 really quickly. I know it's just a lot of like dev environment setup, which I promise you is the most annoying thing about programming in general. So yeah, any questions or comments, or anyone want to say like what went well or what didn't go well? Was it like relatively straightforward? You're able to like figure it out, or I know there's like some complexity, especially for Windows. You'll notice that I use a Mac, and then everything else, I live the rest of my life in Linux. So I'm sorry for the Windows instructions not being crystal clear. But yeah, anyone want to throw something out? Yeah.
Part of the second class, like improving language around cloning GitHub repository, but I noticed that in the earlier in the assignment, we were asked to like set up the SSH stuff, and then with the cloning, for Windows, the instructions were the HTTPS.
Oh,
and not the SSH version of cloning.
Good call out. Yeah. Thank you. Yeah, I'll change that to be the SSH version. Yeah, so going forward, when you clone the repo, oh yeah, you know what? That would be the GitHub Classrooms, like the link that's generated, or to accept it. No, you accept it, and that's an HTTPS request. And then when you go to your repository, when you hit code, you have 2 options. You have a couple options, HTTP, sorry, and then SSH. So since you have your SSH keys now in your GitHub repo, you can clone using SSH, and that experience will be a bit smoother. You're not going to you won't have as many like identity challenges when you go to commit your code. Yeah, thank you. Good call out. Anyone else? All right, cool. Loved the engagement in Slack. I had a couple of shout outs, first question, that's scary. That is scary stuff to be the first person to be like, hi, I had an issue. So really, really, really appreciate that, that energy. Adam had the most answers overall, just like really engaged. Sky, best eye for detail, finding that missing date in the syllabus. And then I just wanted to point out the best question I thought from the week, and it's not really because of the question itself, it's more because of how it was asked. So I just want to like point this out. So a couple of things that were great, and this is, if you've ever like been on Stack Overflow and then all the comments or all the answers below the original question are just like ragging on people why their question sucked, right? Do you ever see like it's not? I mean, anyway, so this is how we get like better feedback from our questions. So having trouble installing Python through PyEnv. Great, we already know like what it is. I mean, ideally, he's in Windows PowerShell, so that's stated right off the bat. As admin, also good. We don't have to be like, oh, did you run it as admin? And then the execution policy is bypass. Amazing. We have so much information just from that. We can rule out so many things already. When I'm installing PyEnv, my Choco version is, Yeah, that's great because then we don't have to be like, okay, well, this was fixed in 2.29 something something. It's like Choco version is 2.3, PyEnv version is 3.1.1. Gives the exact command trying to run pyenv install. And it states, and here's the error message, right? Pyenv install definition not found. And when I list available versions, the latest is 3.11, right? So that's a really great question because it's just limiting so many of the search space requirements, right? The back and forth we might have had to do with him in order to get the fuller picture of how to get to the bottom of the issue. Does that make sense? Yeah, cool. So asking questions like that is amazing. I also really love when people put screenshots. Screenshots give you so much information, right? Like, like which terminal, which shell you're using, where they are in their directory, what the exact error message is, things like that. So yeah, and then one other thing is, and I didn't say this before, but like if someone does answer your question, it resolves your issue, go ahead and give that comment a green check. Thumbs up can sort of be ambiguous. Can be like, hey, thanks for the help. We'll go try that out. But the green check, I think, is pretty unambiguous. Like, this solved the thing that I was having trouble with. Yeah, and then I can assign extra credit accordingly. Everyone who engaged in Slack, we all got our extra credit in different ways. I can be transparent about that and like add it to D2L. The wrong charger. Okay. I can add it in D2L, or I have a spreadsheet where I'm tracking everything. I could do it like once a month, or I don't know. Up to you. All right. So we also did our pre-assessment. I wanted to talk about some of the results from that. As far as like your top 3 technical skills, lots of SQL, lots of Python. There's some JavaScript, like a little bit of diversity, but this is really great because it gives me a feeling of like everyone's kind of in the same, we're all sort of in the same space, right? I didn't see a huge amount of like, if like half the class was like, the TikTok latest trend is learning Golang, and then like everyone knows Golang, and then I'd be like, okay, great, we can pull that in. But yeah, it's pretty much like across the board. That's really great. A little bit of API dev, some Wireshark, some networking. That's really cool. Yeah, but it seemed pretty even across the board. And then as far as like soft skills, I asked this because I was thinking about like, does this group need some help putting teams together, right? And if we're to do that, like how might I, between the technical skills and soft skills, how might I kind of suggest people for each other? But, kind of, which makes sense because we're at Eller, communication was really big. So that's great. That's, the core soft skill that you need, I think, in life. Management, teamwork, it seems like everyone's kind of on the same page about how they think about soft skills and what they think they have to contribute, which is great. So, and then as far as what people want to get out of this class, I was really stoked to see like almost everyone was like hands-on. We want hands-on experience, we want practical experience, architectures, applications, practical. It was lots of words like that. So that's really great to see. People aren't as interested in like theoretical understanding. So that makes me happy because I think you'll enjoy the rest of the assignments. That people were like, I would like to, write a white paper about, compliance for something. I'd be like, oh, we're in the wrong class. But it looks like we're all here doing the right thing in the same place. So that's cool. All right. So I wanted to talk about the group projects really quickly. I have in D2L, there's a few links about the group projects. There's like the overall description, the summary. I posted some rubrics for what I'm kind of expecting for the group project. But high level, what you're going to do is working in teams of 4. You're going to pick either fictitious or real world business problem that you're going to solve with ML or AI. And by that, I think I got on my soapbox in class 1. That could be old school, just traditional statistical ML. That could be deep learning. That could be generative language models, whatever you'd like to do. Once you pick your business problem, again, real world or fictitious, you're going to appropriately find a model that fits the task and fits the data. So if you try to sprinkle a generative language model on something that has nothing to do with language models, that's going to be an issue. But we'll do a check-in about that mid-semester. That'll be part of your mid-semester update. Then you're going to design your architecture. Basically, you're going to serve this model in the cloud for real. By the end of the course, I'd like to have a working inference endpoint. So you'll have your architecture that includes data storage, data preprocessing, your model training should happen in the cloud, and then a model inferencing endpoint with a working API. And some sample data that I can use to call. I'll just curl the endpoint and then get the response back. It doesn't have to have like a full beautifully designed web UI, anything like that. It's not a web dev class. I really just want a working endpoint that I can call. So yeah, and then we're going to host it all in DigitalOcean, not because it's like that's the place to do it, but just because we have free compute. So, this is as a semester long project, running this in Azure or using Databricks or using AWS would be prohibitively expensive, just straight up. So we're going to do it all in DigitalOcean. And I encourage you to get started, start poking around with things like learn more about droplet sizes, learn more about like managed databases. You can use any of the services that we have for offer either in the platform as a service or infrastructure as a service. And we'll talk about a bunch of different ways you can piece all this together and have a working model at the end of the semester. Yeah, so that's the overview of the project. Any questions there? There's like more details about, there'll be a report and a presentation, and then you'll have this API endpoint that I'll call. So that'll be the full thing. Again, mid-semester update, I have minimal, kind of like what I'd like to see for your mid-semester update. And then the end of the semester, we'll have our presentations. And then your report is due the last day of class. Sound good? All right. Yeah. So again, it's not an ML or AI class, right? You don't have to like propose a novel architecture, right? You don't have to create like a new attention mechanism. I'm not looking for that. I just want you to have this business problem that you're thinking about, and then I want a model that fits that problem. That's I'd like that level of critical thinking, and not just fits the problem, but fits the data. So if you're going to go with a supervised approach, how are you going to get labels, right? If you're doing fraud detection, how are you going to get labels? How can you do like ongoing labeled fraud detection? It's a really big challenge. If you solve that, let me know. Or if you are writing a chatbot, that's great. Use an LLM. Fantastic. Are you going to do any retrieval augmented generation as part of that, right? Is it your company's documentation or support playbook or something? You want to use RAG along with your model. It all needs to be a cohesive story. So even if you're not like an expert in ML or AI, you can still find models that fit the problem. That's what I'm really looking for, because turns out not a ton of people in the industry are very good at doing that. So I'd like to send all of you off with that skill. And so also one of the things when choosing your groups, just really think critically about if you're going to work with your friends or if you're going to work with colleagues who have different skills than you, because turns out that MLOps in a business setting is really, really interdisciplinary. We have the machine learning research side, the machine learning engineering, which is kind of separate from the ML, like model development. There's some DevOps, there's some security, there's networking, there's product management, project management, there's database design and optimization. I know everyone here has good foundation in that, which is great. But then industry doesn't always understand that. A lot of management industry doesn't know that ML research and ML engineering are different disciplines, or there might not be budget to have both roles filled. They might not understand the unique security concerns with machine learning and with ML ops versus just DevOps or DevSecOps. A lot of management doesn't know what AI is. They'll I don't know, it's just this thing. It's out there in the ether. We have no idea. So these are some of the challenges that you're going to be facing as you go into industry in whatever role that you're in. So I'd like to make sure everyone kind of comes together in groups where you can share your expertise with your colleagues in a way that makes everyone stronger. Yeah. For groups of 4, you're going to self-enroll. There's groups in D2L. And add your groups, try to have your groups by September 10th. That would be really great. Did you have a question? I'm sorry. No? Okay. Try to add your groups by September 10th. If you need more time, let me know. It's fine. Yeah, joining a group is not graded. It's not a graded activity. It's just, but maybe it should be. Maybe I should do this. It's not trivial to pick a group. Okay, so with that, let's get into the lecture proper. Lecture 3 is we're actually going to start working with cloud computing. Amazing. And noting that I have exactly 1 hour, this might fly a little bit. So if we don't get to everything, the very last bit of the lecture is really just going through details of creating VMs in Azure specifically, because their UI really helps illustrate a lot of different details about creating VMs. And I like that about them. But if we don't get through everything, I actually have already uploaded some video recordings of walkthroughs of creating VMs in the Cloud Console in Azure, AWS, and GCP. So you'll get kind of more familiar that way. But yeah, as long as we get through availability groups, I'll be good. Or availability zones, rather. Okay, so just recall some of the characteristics of cloud computing that we went over. On-demand usage, You control it as the customer, you spin it up, you take it down, you do what you want, right? You don't have to call Zara, can I please have a droplet? It's ubiquitous access. You can get it from anywhere, right? You access it over the internet. Multi-tenancies, that's like resource pooling. So we have all of our servers, you're sharing infrastructure with other customers. Sometimes multi-tenancy is talked about more specifically, granularly within like software, if you're sharing the same software instance with others, and then how do you secure that? We also talk about it in terms of like infrastructure as well. Elasticity, that means that it can respond to demand. You can scale you can have multiple machines in proportion to the amount of traffic that's hitting your web server, for example, and then you can scale it back down when that traffic is no longer as high. And we have measured usage. You can see exactly what you're using. You can measure what you're using. You know how much it costs. You know how much bandwidth. You know how much compute and storage and all those things that you're using. And then resiliency, this is just this idea of like, if things break, you can have redundant architecture. You can have other things in place that are going to help you bring your systems back online very quickly. So we're going to talk a lot about how that works in the cloud. Okay, lecture 1 is going to map to these topics: on-demand usage, ubiquitous access, multi-tenancy, and resiliency. So keep that in mind. What did I do? Okay, we also talked about the 6 advantages of cloud computing. Like there's 6, specifically and exactly 6 advantages. No, this is just how we think about some of these advantages. Trading capital expense for variable expense, benefiting from economies of scale. We're not guessing capacity anymore. We're going to get a lot into that. Increasing speed and agility. Your time to go to market is significantly reduced because you don't have to wait for procurement of all of your hardware and then building a server room and then spinning that up and then deploying your software. You can stop spending money running data centers, and you can go global in minutes with CDNs. So we're going to talk a lot about economies of scale and increasing speed and agility. Oh yeah, I should have also highlighted guessing capacity. Apologies, I will fix that for next time. So what are we going to cover today? We're going to talk about virtualization and more specifically hypervisors. We're going to talk about virtual machines, virtual machine images, and then as we get into the virtual machine resources, we'll talk more in detail about images and about VM sizes. Okay, so what is virtualization? Has anyone heard about virtualization? You ever heard the term? Yeah, a couple times around. Maybe in what context have we heard about virtualization? VR, right? Yeah.
Of it as like a precursor to cloud computing, or like the early stages of it when it came out.
Yeah, it's a precursor. We'd even call it an enabler of cloud computing. Yeah, absolutely. So virtualization is really just taking something that is physical and real, that exists in the world, and creating a virtual version of it, kind of a fake version of it, right? It's the abstraction of some physical component into what we call, a logical component or a logical object. So in our case, this is going to be converting physical IT resources into virtual IT resources. They are ephemeral. They don't really exist, right? You can't pick up a virtual machine. It's not like your laptop. And more specifically, when we're talking about virtualization in the cloud world, we're talking about creating a software-based version of the underlying hardware. Yes.
Like compare and relate to things like digital twins.
Oh, great question. Okay, digital twins. Yes, I would love to answer this question. I'm a little bit nervous about time, but yeah, digital twins are kind of like yeah. I guess you could think of digital twins as virtualization, but digital twins is sort of this idea where you're creating an entire software-based version of a thing that you're studying in the real world. And it's going to have all of you're going to try to have parity as much as you possibly can. So if you are using particular hardware, you're going to emulate that hardware. You're going to use a QEMU emulator. You're going to have like kind of as much as you can a virtual version of that exact same thing. So digital twins happen a lot when we're testing like aircraft software, right? Or embedded systems for aircraft, things like that, all over the place. Excellent question. Closely related. We're not really creating digital twins here, but we could. And that gives me ideas. Let's talk after class. All right, I'm just kidding. I'm not going to hold you to that. So yeah, physical to virtual, right? We're creating a copy of it. Okay, so let's say that this is you. You're this cute developer here. You're so pretty. Well done. You're sitting there, you're working on your laptop. and it's got some CPU, it has a disk, maybe it has some networking interfaces, maybe it has a GPU also. This is going to be your physical infrastructure, right? It's your physical stuff. Maybe you're running Windows 10, and yeah, then Windows 10 is, interfacing with your underlying hardware, right? We talked about operating systems last week a little bit, high level. Your operating system is going to kind of allocate your hardware to your applications. Okay, so because you are a good developer, you have a few dozen tabs open, and half of them are Stack Overflow, right? You also have your IDE open, so maybe VS Code, and then you're playing music on Spotify, Lo-Fi Girl, whatever it is. And then between the applications that you're running and the hardware in your laptop, you have your operating system again. So let's say it's Windows 10. So the operating system, again, is going to allocate the resources to these applications. Okay, so now because maybe you're a desktop software engineer, your application, it's working great locally, but there's a requirement to test it not just on Windows 10, but also on Windows 11, because it's 2024 and Windows 11 is a thing, which I, kind of neglected in the assignment. There's also maybe a requirement for that application to run on Ubuntu. So you need to make sure you have Ubuntu support. And maybe you've gotten into like pen testing recently, cybersecurity pen testing, and you've heard something about Kali Linux. So you really want to run Kali Linux also, and you want to start playing around with it. But so now we want a couple other operating systems, right? And without virtualization, we would basically have to have separate, distinct hardware for each of these operating systems, right? Because you can't really have them both. We talked about kernels, right? You kind of can't have two different kernels trying to control the underlying hardware at the same time. That wouldn't go well for anyone. So rather than having to run 4 different machines to have 4 different operating systems, we have something called a hypervisor. And so the hypervisor is the virtualization software. And yeah, so once you have virtualization software, you can run all these other operating systems without needing any additional hardware. So you can share your laptop's physical resources, right? The CPU, and the RAM, the storage, and the network. And it's going to make it possible to run everything on top of that. So couple of new terms. We have now our Windows 10 machine or our laptop. We're going to call this our host, right? It's our host machine or the host operating system. And then all of these other operating systems are running as guests. So those are guest OSs or guest machines. And again, that software that's running between your Windows 10 machine and your guest OSs is called a hypervisor. Any questions here? No? All right. So let's talk a little bit more about hypervisors. Again, just to repeat this and beat a dead horse. So the software is going to be it's the hypervisor software that runs on the host, your laptop, your desktop, or your server, and it's going to virtualize those underlying hardware resources. That's its job. So it's going to basically take those resources and it's going to divide those resources into subparts, which we call partitions. So your hypervisor is going to partition, your CPU so that it can be available for other operating systems running up here. Okay, so once again, hardware, host OS, hypervisor, guest OS. And this environment, this setup that we have here, like some examples that you may have already played with a little bit. There's, for example, like VirtualBox from Oracle, if you've ever used VirtualBox. So basically, it's just going to create virtual versions of all of your hardware or resources for your guest machines. And these guest machines are now, we can use the term virtual machines, right? So once they have access to everything that they need, they are now like virtual machines. We have our guest OS, and our guest OS is now running on a virtual machine. So Windows 11 is its own VM, or VM we call them. Ubuntu is its own VM. Kali is its own VM. Does that make sense? Cool, great. So the hypervisor can only allocate the resources that the underlying hardware has available, right? So if you have 8 gigs of RAM, usually like a older laptop or something, and the host Windows is using 4 gigs of RAM, and one of the VMs, maybe Windows 11 is using 4 gigs of RAM, you have nothing left for your other operating systems. Like it's virtualizing the actual resources that are there. So it's not totally fake. It's just like allocated and partitioned and available that way. Okay, so this whole setup that we've been talking about, this is called a type 2 hypervisor. We kind of started there because it's a little bit more concrete. Like maybe you've already played with type 2 hypervisors, like maybe you have uh, um, yeah, VirtualBox or Parallels running on your Mac, so you can have multiple OSs. That's known as a type 2 hypervisor. And that's going to be installed on top of the host operating system itself. So mostly used for personal computers, very rarely used outside of that domain, but yeah, that's type 2. And so then what's a type 1 hypervisor? For a type 1 hypervisor, that is going to be running directly on the hardware, right? We don't have an operating system in between. The hypervisor kind of is the software that's going to be in between your hardware and your VMs. Make sense? Right. We also call these bare metal hypervisors because they're literally running on the metal. They do the same thing that type 2 hypervisors do, right? They control the hardware resources on behalf of the guest OS. And then you can install any operating system that you want to on top of that hypervisor. This is really used for servers, right? And this is what clouds use to virtualize all of our resources for customers. But it's not just clouds, right? A lot of IT infrastructure will run a type 1 hypervisor so that you can have more than one application running on these big beefy servers that you've just acquired and installed. Okay, so here are some really common type 1 hypervisors. There's Hyper-V, which is Microsoft hypervisor. Let me come back to that. I'll come right back to it, I promise. Let's go to vSphere. So vSphere is offered by VMware, which is now Broadcom. I forgot to update that, but yeah, Broadcom, VMware, those are now the same orgs. So yeah, vSphere is their their hypervisor offering. Yeah, it's not used as commonly in public clouds because there is some licensing around it, right? It has kind of this proprietary nature. So there's licensing issues. There's also like, you're kind of waiting on a particular group or one vendor to send patches out, things like that. One of the biggest open source hypervisor is called KVM, or a kernel-based VM. So that's an open source Linux-based hypervisor. And it has this kernel. The kernel in it is called kvm.ko, but you don't need to know that. It's going to be it's going to be platform specific in the sense that like you either have to run the KVM Intel KO kernel or the KVM AMD KO kernel. But again, like the cloud will have that provision for you. It's just that when you go in to make a VM and you select an Intel architecture and the cloud's using KVM, it'll have a different kernel. That's just all I wanted to say about that. But yeah, this is also what DigitalOcean uses. We use KVM, and we have both Intel and AMD available. So now let's get back to Hyper-V. Hyper-V is super interesting because the way that it's installed, you actually have to install Windows Server first, and then you install Hyper-V on top of it, but then it flips you. Then it's like, okay, cool. Now, once you have Hyper-V installed, then it inserts itself between the hardware and the OS. But then like when you log into that server, you're seeing the server like OS that you would normally see, right? So if it's an IIS server, then you can see the IIS server that you're used to running. It's really interesting. And unfortunately, we can't like go into like too much technical detail about hypervisors, but it's really cool stuff. And bug bounties around hypervisors are hardcore. Like I think Microsoft's bug bounty, if you find a bug in Hyper-V, I think it's like $40,000 bug, which is insane. The bug fixes and pushes that y'all are doing in Slack in this class, you're gonna pay off. Just saying, it's not for nothing. Okay, so why do we use this type 1 hypervisor? It's gonna let you have really efficient hardware usage, right? So if I'm DigitalOcean and I have some maybe a rack of 10 servers and they all have 128 CPUs a piece or whatever it is, right? I can basically have my customers just grab the little piece that they need. I can use my server hardware really, really efficiently and really effectively that way. And you as the user, you get to choose how much CPU and how much memory and how much storage you want, because all of those resources they can be virtualized, and we can allocate them from any of these servers in our 10 rack. And then we can also, as a CSP, we can use up those resources by dividing that server into these partitions, which then you are then going to kind of come and rent, and that's going to be your virtual machine. Is that clear so far? Okay, cool. All right, so let's talk more about like the benefits for the hardware itself. If we install the OS directly onto the hardware, then what we're doing is we are tightly coupling our operating system and our underlying hardware. So in the old days, you know, kind of before virtualization was very common, you would have your application server running in your IT closet, and if there was a hardware component that failed on it, maybe and you couldn't replace that component, so maybe it's like old or it wasn't you couldn't repair it or you couldn't afford it or whatever it is, that entire machine is basically useless. And then everything that was installed on top of that operating system, that's all gone. The OS, the applications, the app data, and a lot of people don't learn the lessons about backups, just like straight up, it still happens. So basically what you do when you couple your OS and your hardware is you create this single point of failure. So if that hardware goes, you're kind of screwed. But with virtualization, your operating system is now portable. You can move that machine to any other machine you want. And the way that you can move that operating system, you can move the OS and the applications and the data that you need to run those applications is by creating something called an image. So we'll talk more about that in just a second. But now the server and the software running on top of it are independent. You have decoupled those elements. You can move it where it needs to be. You can duplicate it however you want to. Now it's you just have more freedom, flexibility, reliability, uptime, all the things. Okay, so let's talk more about these images because those sound promising, right? So what's an image? This is going to be this like portable file that we generate from the operating system. You can think about it as like a point in time snapshot of everything that's on that OS. That's going to include your operating system, any of the application software that you're running there, configuration files, right? So, we all updated our SSH config files, all of that painstaking work you do to make sure everything works just right. That's part of the image. And then all the data that was running on that too. You can make copies of it. Yay, you can have an image here, make copies of it, you can distribute it, you can do whatever you want to. And then you can run that on any arbitrary computer as long as it has a hypervisor. And so, yeah, it means that you're no longer dependent on the underlying physical infrastructure. So here's our server, there's a hypervisor in the middle, we have our virtual machine, and then if we just take a little snapshot of that, we have our entire image of everything, all the software that's on that machine. Okay, so for home use, for type 1 hypervisors, VirtualBox and VMware Workstation, all of those, there are these images that are published. You can just go online, you can just find them. So if you want to use like Kali, I think it's just kali.org or whatever, you can just go to that URL and download that image and it's there for you. You have that, you install VirtualBox, and then that's it. I mean, it's not totally that. There's like some complications around like setting it up and making sure that Kali can talk to your underlying drives, all these things. But in theory, it's pretty much that simple. Windows images, you can just visit their official website. Obviously for Windows images, you have to have licenses. But yeah, basically any of these kind of type 2 hypervisor images, they're going to be available online for you. Always check the hash of the image. They'll publish a hash on the website. It'll be like, hey, do this. And then you need to check the hash of that image. But if you're going to deploy an image on a virtual machine through your cloud service provider, the cloud's going to provide that image for you. So we have a lot of like prepared images, and you can just point and click, and you'll be like, I want Ubuntu 2004 or whatever it is. So we have those available for you. You can also bring your own image. So if you take a snapshot of whatever it is you want to run, you can bring that image as well. And you can also create new images off of like something that you've already deployed in the cloud. If you're like, oh my goodness, why didn't we make an image of this? If it's already running, you can create a new image. And there's a lot of documentation. Just each individual cloud will have their own procedure. And then you can reuse that wherever you want to. Okay, so let's recall like the kinds of resources that we can use, right? So all the resources that we talked about last week that we use in computing, we talk about like underlying CPU, we talk about network, memory, storage, all of those. In the cloud, we basically have virtual versions of all of that. So here's some of the things that we've virtualized that are available for you to use in the cloud. So it's not just VMs, right? It's also like virtual servers, which really are just VMs, but then we have the server operating system kind of running for you. Yeah, it's just a VM with server software, basically. But sometimes that matters because if you have a Windows license or you need to use a Windows license and that's already provisioned for you, then that's really cool. That'll probably be on Azure, right? We have virtual networks. That stands to reason. And virtual networks are just going to be, pools of nodes that are all connected to each other, but using virtual links, virtual network cards. It's all software-defined networking, and we're going to do a lot of that in about 2 weeks. There's virtual storage. So basically what we do is we have this massive pool of storage, and then we're going to provision that for you as needed or as requested. We have virtual firewalls, so like software appliances. So, you can customize exactly what traffic from where can hit your virtual machine or your VSI, whatever it is. But that's all virtualized. And then we have these things called load balancers, which again, we'll talk about a lot. But a load balancer is just basically it's a virtual switch-ish, but it's going to allocate traffic per your recommendation or per your description to duplicated resources of whatever you're running. So you have a load balancer, maybe you have 4 different VMs running your web app, and your load balancer will be in front of it. It's going to kind of equitably distribute the network traffic that's all going to these redundant application servers. So lots of things can be virtualized. They're just software versions of all of the underlying hardware. Okay, so some practical applications of this. Resource efficiency. Before virtualization, each of these applications and application servers needed its own dedicated hardware. IT shops they just kept each application running on its own computer. There's a lot for reliability reasons, also for security reasons. We can't have our web server also running on our database server, and nor should you, by the way. But you just had to have dedicated server, a dedicated hardware for everything. Then each server basically ends up with a lot of time where it's being underused. If it's an application database that's for your employees and your employees all went home for the night, then that application database is just it has all this compute. It's pretty beefy, right? Maybe it has really, really high IOPS, and it's just kind of hanging out there. It's not doing anything. So you're underutilizing your hardware. You're underutilizing your resources. Again, with virtualization, you can run several applications on one server. Each in its own VM, and they can each have their own operating system. You don't have to. It also means you don't have to be as tightly coupled to Windows world, although it's really hard to escape once you're in. So good luck. But you can also improve your reliability with virtualization, right? So if you take a regular snapshot of your VM, which is kind of way more efficient because you can compress that one image and then uncompress it and then have that available. Old school backups, those take so much bandwidth, so much time. It's kind of easier to just create one snapshot and you have that persisted. Easier management. So software-defined VMs can be managed via software-defined policies. We're going to talk about this. It's called infrastructure as code, and it runs the cloud world. Basically, you saw how painful it was to set up your own dev environment. Imagine having to set up a dev environment so all of your applications can run, right? And then there's the one dude who knows how to do it from back 5 years ago, some whiz who came in and set up that server perfectly, and then he left, and now you have to replace the hardware, and you need to know exactly what he did, but documentation is hard to come by, et cetera, et cetera. You can see the issue there, right? So with virtual machines, you can define all of this in code. We do these via configuration files, and they're all done in a syntax called YAML, which is yet another markdown language. And we're going to be spending lots of time with YAML. It's going to be fun. It'll be your best friend. And yeah, we'll go into this when we do our infrastructure as code lectures in later weeks. There's reduced downtime. Why would there be reduced downtime with virtualization? Yeah.
As you were talking about if you just have one computer running an application that computer goes down, then that process isn't running for however long it's needed. Whereas if it's running on the cloud, if a drive breaks in the cloud container, it doesn't really matter. It doesn't affect you as a client at all.
Sure, yeah. And that's really because we have these images, we have all these configurations, we have everything kind of packaged up, right? then you can just deploy it to the next machine. You don't have to wait for procurement, right? You don't have to wait for Apple to ship your next laptop or whatever it is. It's just available. Yeah, did you have another point to add?
That like some of the downtime also comes in preparing the system to the point that you were at previously. If you have an image that was saved maybe 24 hours ago, it's a lot easier to get those 24 hours than get however many years you have working with the system.
Yeah, totally. It's like point in time snapshots. Absolutely. Yeah. It's a really great point. So we even saw this with PyEnv a little bit, right? So like we all installed PyEnv and then it gave us, PyEnv as of, what was it, 2022? I don't know if anyone read my long thread about why PyEnv, when we install it, only shows you up to Python 3.11. I did a little nerding out, some rabbit holing, but yeah, it's like once you download it, it's going to give you that application as current with the latest release, which was in 2022. The latest release of Python in 2022 was Python 3.11, ergo it wasn't available in PyEnv. So you have to update PyEnv so you can get the latest things. Same could be true of any of your, any of your software resources that you need to install in order to run your application. So if you have a point in time snapshot, then you're up and running. Maybe you're out 12 hours of data, but that has varying levels of impact depending on what kind of organization you are. Yeah, and then there's also faster provisioning. So buying, installing, configuring hardware is so time consuming. Yeah, and with virtualization, the hardware is already there. It's already in place. You just, flick your VM onto it and then it's all there, runs a lot faster. Cool. So we have different names for virtual machines in different clouds. For AWS, we talk about EC2. If you heard about EC2, that's Elastic Cloud Compute, and that's the AWS virtual machine world. We call these EC2 instances. For Azure, we call them virtual machines. For GCP, there's the compute engine, and we call these VM instances. And then for DigitalOcean, we call them droplets. I don't know, because we have to be special. So how do we choose the right image and how do we choose the right size, right? The size is going to be the resources that you select for your virtual machine. So for the image, I mean, you'll see how many are available. It's insane. But you kind of have to think like, do we want, if we're running Linux, do we want something from the Debian family? Do we want Red Hat Enterprise Linux? If so, like which release are we looking for? Do we want the latest and greatest? Do you want the latest stable? Do you want the latest whatever? Or, as your application maybe it has been updated in a couple of years, you have to use an older release. If you want Windows, what version are you running? Windows Server, or are you running IIS, something like that. And then there's specialized images. So clouds more and more are offering specialized images. So if you need a particular, maybe you're doing emulation, maybe you're doing digital twins, and you really need QEMU. You need a QEMU image so that, or an image that will support QEMU running on top of it, because then it's virtualization all the way down. It's, whatever, it's meta virtualization. But you might need a special image for that. We also are offering special images for machine learning applications, because if anyone's tried to, train a model on a GPU recently without like a custom image available, yeah, getting all those NVIDIA drivers installed is like, it's not trivial. This is pretty difficult. So clouds will actually offer these images available for you that are just there. They'll be called like ML in a box or something like that. And they'll have all those drivers available for you, custom NVIDIA images or whatever it is. So those are highly specialized for a particular task. Yeah, then as far as the size, like the resources that you're using, we call them sizes. So it's going to be like, how many CPUs do you need? How much memory, storage? Do you need GPU for your task or for your application? One thing to know is that because of we took a quick look at how big, what the global infrastructure looks like for major clouds. Not all sizes and all images are going to be available in every region. There's a lot of US Western bias there. So a lot of that stuff is going to come out in the US first. And then, yeah, the poor UK, like they get they get second class treatment a lot. Yeah. Australia generally doesn't have the latest and greatest. It's like literally harder to get things there. Like Australia is usually the last to even get like a lot of networking resources. It's, we're working around the entire world. So things kind of come out in different regions at different times. I don't think that we'll run into any of those problems here because we are US based students. But if you do run into that, or if you are deploying something globally, just keep that in mind, that you need to make sure it's available in every region that you want it in. Yeah, so key takeaways from virtualization. It's the foundation of cloud computing. Like we don't have the cloud without virtualization. We don't have the cloud without hypervisors. When we're creating a VM, what we're really doing is we are renting the compute and the network and the storage resources that we need from the cloud. Just renting that time, right? Renting those resources. When we spin up an instance of a VM on the cloud's hardware, I'm sorry, that's what we're doing when we're creating a VM, is we're spinning up an instance. And that same server hardware can be shared with other customers in a multi-tenant environment. We are going to partition our compute resources using these hypervisors. And then your image is going to be the software that's going to define what that VM instance is going to run. Sound good? All right, that was a lot of stuff about virtualization. So if you have other questions, if you think of anything later, definitely put them in Slack. We're doing well on time. Okay, so where are we? In the last 3 lectures, we have covered so much stuff. So I just want to like position us in case like all these different concepts that we've talked about, like where we are now isn't quite as clear. So we talked about, cloud deployment models, right? So public cloud, hybrid cloud, private cloud, and multi-cloud. Does that sound familiar? Or if you weren't here for the first lecture, you've watched it online? Hands up if that sounds familiar. Okay, cool. Yeah, great. And we talked about cloud delivery models, right? So software as a service, platform as a service, and infrastructure as a service. We've talked about like hypervisors, and that's the hypervisor world, applies to all of these, but we're talking about them a lot in terms of infrastructure as a service when you're actually provisioning a virtual machine, going in and creating it yourself. That's like solidly in the infrastructure as a service world. Yeah, we talked about all the different resources that you can virtualize in the cloud. So now we're looking really specifically at compute, EC2, Azure VMs, GCP instances, and DigitalOcean droplets. So public cloud, infrastructure as a service, compute. That's where we're at. Cool. All right. So how do we understand the details of virtual machines? So in Slack last night or today, I asked, just make sure you can log into portal.azure.com. Go ahead and do that now, because I'd love to like do a walk along, just or ride along with this. And we'll kind of walk through the steps of creating VM in Azure. And again, if we don't finish everything, I have a recording available for you so you can kind of step through it. Sound good? So I'll give everyone 45 seconds to log in.
Groups. Biggest challenge. Doctors getting antibiotics.
Okay, go ahead and raise your hand if you've logged in, if you're good. Yeah, all right, amazing, great. So, because we all created our accounts already, excellent. Okay, so the Azure portal may or may not look like this for you, but it should look something similar to this. What we want to do is we want to go ahead and create a virtual machine. So there should be like a plus icon or like a create resources. You'll do that and you create a virtual machine. So just let me know when you're ready and we'll go into the VM settings. Yeah, I like this. Yeah, like a thumbs up if you're like, good, you're in the page. Okay. A green check, please. Yes. Okay, so let's start off from the top. So if you've hit create, then you should see a screen like this. Are we here? Yeah. Okay, amazing. So settings, whatever. You want to use your Azure for Students subscription. There's lots of clouds have lots of different subscription like models that you can use. This is really applicable as like you get like deeper into cloud world, because you might have some subscriptions that are really, really cost effective, really cost saving for you. If, for example, you're running a school, there's particular licensing for that, or a nonprofit. Or if you have an enterprise of more than 10,000 people, you'll have different kinds of tiers of subscriptions. If you don't have Azure for Students available here, You should, but if you don't, it's okay. Don't worry about it. Like message me later. We'll come back to it. So one thing that's really important to think about is these things called resource groups. They're called different things in every cloud. Sometimes they'll be called, like in AWS, they'll be called like, projects. In DigitalOcean, they're called projects, right? So it's just a way of like logically grouping resources together, and don't neglect your resource groups. Like it's really important to have it all in the same place. You might have like 8 different development teams all running resources. And if you don't have like your resource groups, thought through and set up, then things will just kind of become chaotic. Things in the cloud get chaotic real fast. So having logical ways of organizing things is critical to think about from the start. So, for a resource group for our class, for example, we could do like MAS 2024 or MAS 547 24 assignment 3. No, lecture 3. This is lecture 3, not assignment 3. Whatever, it's fine. But so next we're gonna have things like our regions. So if you scroll down a little bit, we'll have the region, and you'll have availability options, including an availability zone. You'll have virtual machine scale sets and availability sets. And one thing that I really like about the Azure portal is that like they illustrate these things really well. So let's talk about high availability, redundancy, and failover. So we'll kind of back out of the portal for just 1 second. Don't close your tab, but let's just get into this. So high availability, that is just, well, not just, it's this really difficult thing to do. High availability, sometimes we have these service level agreements or SLAs, and SLA expectations are going to vary from cloud to cloud. They vary from like, B2B a lot also. And some SLAs for high availability are going to have things like 99.9999% uptime. That is your expected uptime. And if you are, for example, a hospital, that has certain implications. If you, if it's any kind of fintech, financial services, you have really specific expectations of uptime. And so this is how we kind of handle that. Or one of the ways is through high availability and how we enable that. Redundancy and failover, if something fails, do you have a plan in place? So it's automatically something else will catch it. We're not gonna just wing it, right? Like we're not just gonna, I guess this failed. Let me go spin up a new VM and like type it, or let me call someone at 3 a.m. No, we have failover baked in, right? And then also like redundancy. So if you have if you're a victim of ransomware, for example, you have like redundant systems around that are isolated, that can come online. So in order to handle that, we have regions, and all clouds will have kind of this sort of structure. We've got regions, availability zones. Scale sets and availability sets are more technical implementations, but regions and availability zones refer to the actual physical like data centers. So regions, there's data centers all over the world. This is just Azure's regions for North America. And so there's really common ones are like US East, US West, there'll be US East 1 and 2, US West 1 and 2. Sometimes they'll be called like SFO, so like San Francisco or NYC, but like they'll give you some idea of where that region is. And you can choose a region for your stuff to live that's ideally closest to your users. So if you're spinning up resources for your company, then it'll be closer to your developers. If you're spinning it up for customers, it'll be closest to your customers. And you can select where you want your services and your data to reside just by selecting that region in that box. So it's gonna be like, okay, I would like this VM provisioned in Toronto, for example. So also Azure has this really cool like interactive map. There's a URL here, datacenters.microsoft.com /globe/explore. It's pretty slick actually. You can like play with all different toggles, like what's available where. So then we have availability zones. So these are going to be within region redundant infrastructure. So in the US West 1 region, there are going to be multiple data centers set up as availability zones within that 1 region. And then there's protections in place in case one data center or in case like an entire availability zone fails, which can happen. What happens is that these data centers have different fiber paths connecting them. They, if something is like close to a mountain, the next availability zone will be like closer to the ocean, right? Like people like think through like any kind of like physical disaster or natural disaster that could happen to one of these data centers, and then provision redundancy in that same region. So it's like it's hardcore, it's hardcore engineering. Not all Azure regions are going to support availability zones, unfortunately, but a lot of them do. And so, you'll want, if you have a requirement for high availability, then you want to make sure you're deploying your infrastructure somewhere that has, availability zones for that region. Okay, now scale sets. So scale sets are different because once you've deployed your stuff and it's in a region and you've chosen availability zones, then you have things called scale sets. So this is basically your virtual machine is going to be deployed by default as like a little group of virtual machines. And those can be provisioned across availability zones. And that's going to allow your applications to scale in response to demand. So you can say, okay, for my scale sets, I want to make sure that if the demand reaches this VM and it kind of maxes out, I want minimally like 5 more to pop up at the same time. And you get to configure all of that on your own. So this, again, provides high availability of your application. So see how we're baking high availability into every single step in the cloud. We'll get into that even more with microservices. But it's just, we think about this all the time. We obsess about high availability. So then if one VM isn't available, traffic is going to be automatically routed to the next one that's available. These are going to, again, mitigate single points of failure. And the cool thing about scale sets is it's going to automatically duplicate your VM across a fault domain. So a fault domain is going to be a group of virtual machines that are going to share a common power source and a common network switch. So if you have all of say we have, I put my markers here. Yeah, so say we have we've deployed our stuff in one region, and then we have availability zone here, and one here, and then one here. Here are, a couple of data centers, sort of set up in our availability zones like this. If we select that we want a scale set, when we deploy something within an availability zone, we can actually have stuff deployed across availability zones. But if we deploy something here, then if we set up a scale set, it's going to scale that not just within that same, for example, rack or that same data center. It's going to scale it across. It could be like within that same data center, but there's no common power supplies. There's no common networking, right? So it's going to kind of choose the next one or choose one a little bit further from it that has that redundancy baked in as well. So then if that whole rack, if that server fails, then like the next VM that pops up is going to be located on a server that has no common power or network resources shared with it. Yeah.
Power to be like, I guess what do you mean by that? Because I'm just thinking like in Tucson, we have like one power provider.
Oh, sure. Yeah, but we have different substations, right?
Yeah.
Yeah. So generally speaking, unless you're in Texas, generally speaking, our substations are built to also be like fault tolerant in the sense that if one fails, there's failover to the next one, right? So you can have like one data center that is dependent on like one substation. Also in like server data center world, right? You have also uninterruptible power supplies. You have all these things, right? So it's basically going to have like guarantees in place that if power fails for an entire rack, for an entire like room, or for this entire data center, that like the next one over, maybe it is on a completely different substation, right? Or that you'll have a power source that's generated from another place.
Like battery generators.
Oh yeah, there definitely are. Yeah. So the UPSs, yeah. And so basically if power fails in any data center or on any critical infrastructure, you're going to have these UPSs, which like look like these big, I don't know, they look crazy. It's like a huge like amp, like stadium amp size thing for and then it's literally just like things are like just like plugged in. Like you have it plugged into the wall, and then you have like alternative power plugged into that UPS. And then ideally it'll just like fail over, it'll be battery powered. It's kind of charging, and then like if power goes out here, then it'll switch on the battery. And then but those things can drain pretty quickly depending on how much is there and like operating under it. Yeah, UPSs are fun. Yeah. And then if that fails, if the battery doesn't kick on, you literally have to go and like push a button and turn it on. Not speaking from experience, but okay, so let's move on. So we have our next up is our image, right? So if you scroll down in portal.azure.com, the next thing that you have to choose from is your image. And this is where we talked about, look at all these images available. You can probably just keep scrolling. It'll probably have like a show more thing. There's a lot of different kinds of images. And again, you'll start to see some custom images pop up there too. You can also choose your architecture, right? So we talked a little bit about architecture. You can choose ARM, you can choose Intel x64. And then there's something called a spot discount. So spot VMs are super cool, and they kind of tie in with more of the like serverless world that we'll talk about in a couple of weeks. But spot VMs are these things that basically just if you don't have any like high availability requirements, go ahead and use spot VMs. You get this significant discount for in terms of like the runtime, because it's really just like we're selling like kind of like scraps of like less provisioned servers. So you might have like 3 VMs all taking up a certain amount of resources, then we have just a tiny little bit left for this one on this one server. We can sell that to you as a spot instance. So as that capacity is, sorry, I get distracted really easily with this. Thank you. So as we start, filling up all of those server hardware, then if we have any excess, we can sell that to you as a spot instance, but like they can pop online and pop offline pretty much whenever. There's no guarantee for uptime. So like, why would anyone ever want to use a spot instance? Like that seems kind of weird, right? But like maybe you have a task that maybe it just like runs on, we talked about cron jobs like really quickly, right? Like so it's just something that needs to run for 5 minutes every day. And it doesn't have to be on this local machine, but you just need to spin it. And it just needs to run at 9 a.m. every single day. You don't care where, you don't care like, how long, or if it's on the beefiest machine ever, like you don't really need a lot of availability there. That's a really great thing to set up for a spot instance. So you can just kind of provision this. It'll just, when it's on, it's on. If it's not available here, it'll be available over there. Maybe it's not available in this region, it'll be available in that region. They can just kind of pop online. So spot discounts are super steep. I think you can get like a 90% discount on your virtual machine if you, know how to provision it. So, okay. So next up is our sizes. So you have to select a size as you create your virtual machine. Certain things are customizable after you've already created it. You can add more disk, but you can't always take away disk, just how we've provisioned it. You can add more RAM pretty easily, or add more memory pretty easily. You can even scale up like CPU pretty easily. But yeah, if you click that little icon that says like show more sizes, this is a screenshot I took like last year, and there were 591 VM sizes available. There might be more now. So like there's a lot of stuff. There's a lot of different ways we think about our virtual machine sizes. So they all depend on your different requirements. So let's get into that. So there are a few key things you want to keep in mind, right? There's going to be sizes that are optimized. Like you want to think about like your CPU to memory ratio. You want to think about like disk throughput and IO, right? So like how fast you can read and write from disk. You want to think about like graphics rendering, or you want to think about like GPU usage. If you're using a machine for model training, that's going to have specific requirements, right? Model inferencing is going to have very different requirements. And if you don't know what the differences are, don't worry about it. We're going to cover that in like MLOps and get pretty deep into it. But yeah, in general, we have like different classes of virtual machine sizes. So we'll have like general purpose. Most of what we're going to use this semester is just going to have like a nice balance of CPU to memory. So unless you have like a need for another, kind of custom size, general purpose is fine. There's going to be compute optimized. So it's going to be like more CPU, higher CPU to memory like ratio. So that's really good for if you have like medium traffic web servers. Network appliances are good for that. They're doing a lot of batch, if you're doing any batch processing, that kind of stuff, application servers, those things. Memory optimized image sizes are going to be really good for like caching, right? So you have a lot of stuff in memory that needs to be able to be served really quickly. You want a memory optimized VM. A lot of like from my experience, like just training a lot of models, a memory optimized machine is worth so much more than like a CPU optimized machine. I mean, if you think about like clustering algorithms, right? You need so much more in memory in order to like efficiently run these operations. CPU kind of has less of an impact on it. I bet if you've like ever gone to like Google Colab to like, you run out of memory locally on your disks. So you're like, okay, let me go to Google Colab. The first thing you run out of is memory, right? It's like, it's a interesting path. I think people make assumptions about machine learning training, but it really requires one thing or another. But I think memory is really important. You can have storage optimized virtual machines. So that's what you're going to run your databases on, right? You really want to be able to have like a high disk throughput, really fast IOPS. You want, a lot of storage for that machine. So any kind of big data or data warehousing, that kind of stuff, that all wants to live on a memory optimized VM. If you want a GPU machine, those are available. And there's like high performance compute, that's its own set of requirements. That's gonna be really, really beefy CPU with high throughput network. So lots and lots of bandwidth available to you. So yeah, for stock trading, IoT data, DNA sequencing, all of that. Okay, so moving on, let's talk about authentication. So if you scroll down just a little bit, we'll look at authentication. We did this a tiny bit already using SSH keys. I'm going to give the fastest overview of SSH and authentication the world has ever seen. It's really important stuff, and we'll talk a lot more about it in our security unit. But for everything in this class, we're going to do SSH-based authentication. And does anyone want to raise their hand and say why? Why are we using SSH keys when we could just use passwords? You log in as root, you log in as like admin and password, right? But if you create a really solid password, why would we still want to log in as using SSH instead of a password? Let me make that point first. Sorry, there are different kinds of authentication. We have passwords, we have authentication apps, biometrics, we have keys, right? There's authentication in general is the process of gaining access to a system. Authorization is checking that you actually should have that access, right? So it's like authorization is, if you are, in assignment 2, we're going to create some tokens so that we can provision resources in DigitalOcean, right? Our token is going to be scoped to what we need to scope it to. So you can have like the correct token to get you to authenticate to access your resources via the CLI. But if that token isn't scoped, it's not authorized to do certain things. It's not authorized to create a droplet or delete a droplet or delete someone else's droplet or whatever it is, right? So authentication kind of gets you in the door, and then authorization is going to be like, what are you allowed to do here? What are you allowed to touch? Who do you know? So yeah, different kinds of authentication. We've all done it. We do password authentication all the time. You maybe have like a YubiKey, for a two-factor, or a SMS for two-factor, those kinds of things. So authenticating using SSH stands for Secure Shell. And that is, it's both the protocol and also the software that runs the protocol. So that can be like a little bit confusing, but in general, we just call that whole thing SSH. So the SSH key is acting like an access credential. It's acting like a password, basically. And functionally, like SSH keys kind of like resemble passwords, like really long strings of stuff, right? This is using public key cryptography. So that is well outside the scope of this class, but if you're interested, basically it's just made up of 2 kinds of keys. This bit you do need to know. You'll have a public key and you'll have a private key. We call these a key pair together. The public key is going to be for your remote system. You're going to drop your public key onto your droplet. You're going to drop it onto your virtual machine, and your private key is going to stay with you always, right? We never let anyone have access to our private keys. We don't share SSH keys. We don't share toothbrushes. We don't share SSH keys. Understood? Okay, great. You don't even share them across services, right? So if you have a service and it's running on a particular application like that, it should have its own credentials, its own tokens, its own keys. These should all be separate. I see a lot of people kind of actually, I see this a ton. Someone follows like a YouTube tutorial, and the person on YouTube is like, oh yeah, and then you generate this key, and then you whatever, and I've committed all this in GitHub, and they commit their keys into GitHub too, and then it's like, and then all of a sudden it's like, oh, this person who made this tutorial about how to do something in DigitalOcean, now all of those resources are compromised, and then I see it pop up, and some attacker is crypto mining on all of those virtual machines, and I have to go kick them off. Anyway. that's like the least serious side effect of reusing SSH keys or having your private key public. There are much, much more serious consequences. So I've given you your warning. Thank you for listening. Your private key always stays with you. Keep it secret, keep it safe. All right. SSH, very, very high nutshell, like high level. This deserves so much more time than I'm giving it. It's going to basically encrypt the traffic that's going between the two machines, right? So you have your client's going to say, hi, I'd like to SSH to this machine. It's going to have a public key and a private key exchange, or your public key is going to be exchanged. And then you're going to negotiate some parameters. It's going to check to make sure that these two key pairs go together. And then it's going to use that to encrypt these. It's going to encrypt a secure connection between your client and your server. There's a lot more about SSH keys coming up in some reading, and we only have 3 minutes. But so let's try to get through as much as we can. So our inbound ports, if you scroll down, by default, SSH is going to use port 22. Port 22, SSH. Those two things go together. If you don't have port 22 enabled on your remote machine, you cannot SSH to it. It's going to say, no, there's nothing listening here. There's nothing you can't get through. So if you're having trouble SSHing to a remote machine, make sure that port 22 is open. Otherwise you can't talk to it. We'll talk a lot more about ports, but people here are taking the networking class, right? So we are relatively familiar with ports. We know that a little bit. Okay, we'll do a dive on it. Okay, next up is disks. Disks are fun. You have so many options for disks in Azure. They really lay this out in a really pretty great way. There's a lot of offerings. You are going to have provision as part of your virtual machine. This is true across clouds, but they make the terminology really clear. There's your OS disk, right? So that's that's the space that's allocated to you to run your operating system. It won't necessarily have the most room on it. It won't have the most storage on it, but that's the bit where you can actually have your software physically stored. Your operating system, maybe a couple other things, dependencies, some libraries, TensorFlow, PyTorch, whatever it is. Then you're going to have what they call a data disk. A data disk you can think of as kind of removable storage. You're going to mount your data disk. Think of it as an external SSD, an external hard drive, your lazy, rugged 2 terabyte, whatever. That's going to be the disks. We virtualize all that storage and we add it to your machine so you can have additional space to run things. Very helpful in machine learning world when you have 100 gigs of embeddings that you need to then, offload somewhere. And then you'll have a temporary disk. Every VM is going to come with a temporary disk. Don't really interact with your temporary disk. You should just, if you need lots of space, you should use your data disk. Your temporary disk is temporary. It's ephemeral. When your machine is gone, that disk is gone. Then we have things called managed disks. So managed disks are, it's additional storage, but then you have extra bells and whistles. And Azure is going to provision a lot of things for you. In cloud world, we usually have these kind of 2 varieties of services. We have the straightforward service itself. Maybe that's a virtual machine or a cluster, a Kubernetes cluster. Then you have a managed version of that. Then you have managed Kubernetes, you have managed databases, you have managed disks. And that means you've kind of moved into the platform as a service world because we're provisioning a lot of the underlying stuff for you. So you don't have to spin up a virtual machine and then install MongoDB on it and then set up all of your networking and then make sure that you've optimized your bandwidth inbound, outbound, or whatever. You can use a managed database, or in this case, a managed disk. And so it's going to take care of a lot of the configuration for you. So different reasons for using managed disks. The slides are posted, I think, so you can look at these, and we are out of time. We have some more benefits here. Again, I have a walkthrough. And then at just manage disk benefits. Yeah, networking, that's okay. We're going to do so much networking. You're going to be sick of it. So it's okay if we stop here. Thank you all so much. I will see you on Thursday when we're going to start talking about containers and about some of the headaches that they solve. Looking forward to it. Please do look through the rest of these slides. Just scan through them or scan through the Azure thing. And again, I think it's 15 minutes of video that I uploaded. So go ahead and take a look at those. Thank you all so much.
Thank you.
Thank you. Thanks.
Oh,
Hi. Hi.
I'm Raj. So I could not join the starting phase sessions.
Okay.
I was decided on the games and
Okay.
for that, it's beneficial to me. So,
Oh, great, great, great.
I missed those sessions. Is there any way that I can?
The first two, yes, 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 yes. Are you officially enrolled in the class? Yeah, so then in D2L, I've posted in week 1, there's both the course recording and then also the lectures. I've recorded them and uploaded the recordings. Yeah, so you'll have.
I read the assignments because I saw that there was a like a deadline. That's a secret.
Oh, that's great. Yeah, so could you come over to I'll see it. Yeah. I'm gonna able to have a quiz or.
Oh, yes.
What type of. Perfect. Yeah, you're doing great shape. I'm really glad you're joining us. Thanks so much. Yeah. Thanks.
There.
Hi.
I started this too late on Sunday.
That's okay. It happens.
And I ran into so many. Stuck on is I'm trying to uninstall chocolate.
Uninstall Chocolatey because.
I'm just trying to start fresh. all
Okay.
over again.
Um, yeah.
But I can't seem to get there. I
Uh,
try to use the force command. It doesn't let me uninstall it that way.
interesting. You could try deleting the binary, or it's not a binary. You could try deleting. Yeah. Oh, here it is. I'd encourage you to not uninstall Chocolatey. That's probably not the issue. Let me see if people have like quick questions, and then I will be right there. Hi. Hey.
I have a question that is it possible along with this class, this is very that we're getting it, you're teaching very good.
Thank you.
And I had a query if we can also get a cloud certification, if anything the university can provide, so that we can get AWS certified. as well.
Yeah. So if you wanted to do that kind of independently, more than welcome to. If you're having any issues with like accessing materials, I could probably see what I can find. Because I really tried to make the class itself like platform agnostic, like cloud agnostic, like we're using DO for like running our projects, but you know, I'm teaching Azure right now, we do networking on all the AWS. I can't really spend the time in class to help prepare for certification.
No, I didn't mean that. Just
Okay.
getting a voucher or something, if it's
Oh,
there.
voucher.
Yeah. Is
I'm
there
like,
any?
I'll ask around. Yeah, I'll ping my friends. Yeah, I'll see it. Yeah, so a voucher. So do you know which exam you'd like to take?
Either AWS or Azure certification, that will be.
Sure, they have so many.
Okay.
There's so many of them. So like the entry level ones are, thank you, yeah, the associate. And then there's like the practitioner ones, then it goes up from there. So, the associate ones, you know, I'll ask around and I'll see what might be available. Do you think there would be like a lot of interest from students to like all kind of take the exam? Cause
I
in-
hope so.
Okay. And do you know which cloud you'd like to